Okay, we're doing homework number 6. Have it up here, so after every one, I'll just erase the numbers, and then we'll just go on from there. Okay, so let's get started. Number 1 says, is the following mapping a representation of a function? So we have our mapping diagram. I'm just going to draw it really quickly. We have the numbers 1, 4, and 2. And then here we have our numbers 2, 5, -5, and 0. So remember, these are my x values, these are my y values. I have an arrow going from the 1 to the 2. An arrow going from the 4 to the 5. Also from the 4 to the -5. And then 2 to 0. So remember, to be a function, every x value can only have one y value. Okay? So if I look right here on this x value of 4, it has 2 y values. It goes to the 5, it also goes to the -5. So if I have an x value that has 2 arrows coming out of it, remember, that is not a function. Not a function. Okay, if you put no, that'd be okay too. All right, remember, each x value can only have one y value. All right, that's number 1. Let's go to number 2. Okay, number 2 gives, are the following coordinate points a representation of a function? So it gives us coordinate points, ordered pairs. I'll write those in. We have 4, 5, 5, 4, 4, 5, and then 6, 4. Okay, so remember, we look at our x values, so I'm going to circle those. 4, 5, 4, and 6. So I know what you're thinking. You see these 2 4s that repeat, and you automatically say it's not a function. This is a special case. Okay, this is a special case because these 2 points are the same. So my value of 4, my x value of 4, is still only paired up with the 5 here, and it's also paired up with the 5 there. So this x value still only has one y value. So that's why this is a special case. It is a function. On your homework, when we graded it, we told you that you only take 5 points off if you got it wrong. And if you got it right, then you got an extra 5 points. So this is a function. And yes, either or. Okay, so that's something to be very careful to look at. I know you automatically see the 4 and the 4 and you're like, it's not a function. This case, it is a very special case because they're the same points. Now, if this 5 was a different number, say it was 6 or 7 or 8 or 9 or so on, then yes, this would be not a function because it has more than one y value. Okay? All right, let's go on to number 3. Number 3 says, solve the equation 15x minus 110 equals 4x plus 11. So 15x minus 110 equals 4x plus 11. So when I solve for the value of x, remember, I have to get all my variables on one side and all my coefficients or constants on the other side. That way I can get to the coefficient with the variable, and then it's easier to divide. That's all I'm doing. So if I look, I have these terms are not alike. Okay, so I can't combine them or do anything with them. Same thing over here. So what I'm gonna do is I'm gonna get all the coefficients that have a variable, and we're gonna put it on the left side. So this plus 4x here, I gotta take the inverse, which is minus 4x. And I bring it over here and I put it underneath the 15x because it's a like term. I don't put it over here because there's no variable attached to this 110. Draw my line. 15x minus 4x is going to be, not 9x, it's going to be 11x. 11x minus 110 equals, now this z's out because it makes 0, and then we have 11. You can put plus 11 if you want, because it's not going to make a difference. So now I have my variable here. This is a constant that doesn't have a variable. So I'm going to take this and put it over here on the right side of the equal sign. So minus 110, the inverse is plus 110. Plus 110, plus 110. Okay, so 11x comes down. This z's out equals 11 plus 110, or 110 plus 11. Okay, it's going to be 121. So now when I'm here at this last step, this is very the easiest part. We have a coefficient in front of the variable. We just have to divide by that coefficient. So divide by 11, divide by 11. This makes 1, x equals 11. That's how we got our answer. All right. Okay, that's number 3. Let's go to number 4.